All right, what's up, my mathletes? That's right, Mr. Muscarella coming at you, and we're going to take a look at Descartes' Rule of Signs today. That's right, we're going to take a look at French mathematician and philosopher Descartes and his lovely little Rule of Signs, which will help us determine the number of positive or negative real zeros for any polynomial function. Now, in order to work with Descartes' Rule of Signs, we got to actually know what the rule says. And here's what his rule says. The number of positive real zeros of p of x is equal to the number of variations in sign of p of x, or that number decreased by an even number. So let's talk about this part right here. Decreased by an even number. So say we determine that because of the sign variations, we're like, oh, we could have 6 positive real numbers. So if it's decreased by an even number, that means then we could have also 4 or maybe 2. So those could be my possibilities. If I had an odd number of roots potentially, say I start out with 7, then I could decrease that by 2, which would give me 5 roots, and then 3 roots, and then 1 root. So those would be all of my possible variations of, if I have variations in sign, I could have that number of roots. And that's what it means to be decreased by an even number. Now, those are for the positive real roots. And similarly, for the negative real roots, I just got to plug in negative x and evaluate that to see what the changes in signs are. And when you're looking for variations of sign, that's just a really fancy way of saying that you are changing from a positive to a negative, and then eventually from a negative back to a positive. So sometimes we'll see those variations, other times we won't. So let's take a look at example 1 here. And if we look at that very first term, x to the 4th, we know that this term right here, that's a positive term. Now, that's positive. If I look at my next term, notice this term right here is negative. So that's one sign change. And then if I look going from negative 5x cubed to negative 5x squared, that's my second sign change. So I got a sign change there from the first term to the second term, and the second term to the third term. But if I go from the second term, or I'm sorry, the third term to the fourth term, if I go there, there's no sign change because both of these guys, this term is positive and so is this term. So there's no sign change there. But when I go from positive 5x to negative 6, oh, now I'm going from positive to negative, so that'll be my third sign change. So the number of positive real roots is going to be either, I have 3 sign changes there, so that could be 3, but then I can decrease that by 2. So I could have 3 real positive real roots, or I could have 1 positive real root. So those are my options for that. Now when I go to analyze how many negative real roots are, what I have to do is take that function that I was given, p of x, and I'm going to replace all the x's with negative x. And this is going to be a real generic formula. So we're just going to have negative x here to the 4th power. So every single x gets replaced with negative x. So now that we've replaced everything here with our negative x, when you analyze this to say, all right, what is my result going to be? Anything that's got an even degree like that, negative x to the 4th power or negative x squared, those two things, the sign of the result of that is always going to be positive. So that's going to stay as x to the 4th, and our other term is going to stay as 5x cubed. Now, when I look at odd degrees, like negative x to the 3rd power, or my other one here where I have negative x, with those, your result when you take something that's negative and raise it to an odd power, that's always going to give you an odd or negative answer. So on that next term, that negative x cubed, so this part is really going to be negative x cubed, and negative x to the 1st power is just negative x. So when I multiply that, and this is where you got to be careful, watch your sign here, because that's a negative sign in front of the 5. So when you multiply negative 5 times a negative x cubed, you'll get a positive 5x cubed. So be careful on that one. And then on the next term, I have positive 5 times negative x. So that's just going to give me negative 5x. And the constant, that thing never changes. So that's still negative 6. So you just have to be careful when working with your signs and to make sure that you get the correct sign when you're raising terms to an even or odd degree. Now, for the next part, we just got to analyze. And when I look at that, I'm like, hey, first term's positive, second term's positive, third term's positive. Finally, we get a little sign change going from the 3rd term to the 4th term because we're going from positive to negative. But then, going from fourth term to fifth term, man, both of those terms are negative, so I don't have a sign change there. So I only have only one sign change in all of that. So what that means is the number of real roots that are going to be negative. So the number of negative possible real roots is only going to be one possibility. So I have one possible negative real root and 3 or 1 possible positive real roots. And that's all you gotta do for this. Straightforward. Just take your time when doing your replacing, and that's it. All right, so that's it for this video. Come on back, check out example number 2, and I will see you guys shortly. Make it a great day as always, and I'll catch you soon. Peace out.